This is the Clouds Guru and I would like to welcome you to this video on Cisco CCNA and AWS Architect Associate. In this video, I would like to discuss about Cisco CCNA and AWS Architecture Associate, which can greatly help you in deciding whether to start in CCNA or begin your journey with AWS in your IT adventure. I will focus on exam preparation requirements and show you all aspects of how jobs look like. Let's begin. Studying Cisco requires a lot of reading technical books, which are very costly, and in fact, you need to spend hundreds of pounds on them. Cisco's distinguished books about security and Cisco Security have orange covers, while on the other hand, books about networking, Cisco switching, and routing books have green covers. These are the books good for the Cisco CCNA switching and routing exams. They are a bit old, but they are such excellent books, I must say. These books are great examples of my effort to pass my exams a long time ago. Oh well, can you see? Wow! My bookmarks are still there. Now, just for one exam, we need 2 Cisco CCNA books, and each of them has almost 900 pages. And oh, this is not enough. You see? I had another one. Which likely has more than 1,000 pages. And this great book was written by Todd Lamley. I like IT security, but to pass the Cisco security exam, I need to read on top one more extra book. Books good for Cisco and AWS engineers. Are these books common for both? Yes, of course. But they are not essential for AWS exams. TCP/IP knowledge helps you troubleshoot on-prem and cloud network infrastructure, while DNS knowledge is essential for both certificates, but AWS significantly uses it. And you will see how users will know DNS in your future workplace. However, programming is essential for IT engineers more than before. We have infrastructure as code. I recommend studying Python. Lastly, hacking. Reading hacking books gives you the feeling of how hacking works. If you are under attack, you must know how to defeat malicious activity, and as well helps you make your infrastructure more secure. Let's first compare traditional networks for the web server in the data center on-prem to the AWS cloud network. To start with, these are the traditional networks that requires us to be able to build an IT infrastructure. First, we need routers. Then we have ISP routers. And oh, this is a little bit old 2800 series router. And our edge routers are exactly the same models. Not to mention that I did my preparation for my CCNA and CCNP using those guys almost 10 years ago. Now to connect all infrastructure, we need Cisco switches, and here, CCNA knowledge is very essential. To secure the network, we need a firewall. Cisco ASA will inspect our traffic. For higher availability, we need a second one so that we could build our network infrastructure, then web server. But oh, it is a very heavy guy. Then, we need a second one. Oh, and again it is very heavy, and we need to double the servers for HA. But wait. Remember that we should also be needing a load balancer to distribute traffic, and F5 is one of the best. Now 2 again for HA in case of failure of one box, and the second one can carry traffic. But I'm so sorry guys, all my boxes are a bit dusty, I didn't use them for a couple of years. And there you go. This is the beginning. From cabling to racking and other knowledge that will help you set up IT infrastructure. Did you get it? I'm sure it's a yes. The CCNA exam and network engineer job require you to know cabling. The first essential for the job is an FTDI USB Cisco console cable. to RJ45RS232 for routers, switches, firewalls, and other Cisco equipment. The second ones are Ethernet cables Cat5 and Cat6. Then here you can now start your network journey. The fiber cables are single, multimode, LC, and SC types. Then you have Cisco transceivers, which comes with many different types. And don't forget about the Cisco stacking cable. Last but not the least, tools to make patch cables. Do you know that tools? You will be tested with technical parameters for those listed above, and I tell you it is very fun. Network engineers must know how to configure network equipment, switches, routers, firewalls, load balancers, and other equipment in physical or virtual. That's the reason Cisco exam preparation is so costly. I spent thousands of pounds on a number of switches, routers, firewalls, and servers. Physical Lab helps you to practice patching cable to network equipment, and honestly, you should know how to do cabling. What happens if your manager sends you to data center or comms room to patch cable, but you've never done it before? The virtual lab is great, but it often happens that you spend more time solving problems with software than doing the real lab exercises. I remember that I spent hours on GNS3 bugs. Later I solved that problem when I switched to EVE NG Pro version. So we are done comparing CCNA part with full stack of equipment for the configuration, cabling, and has done all the job physically in data center, while on the other hand is AWS, and you are just having laptop and from it you can control all infrastructure. You can potentially work 100% from home, and just using only laptop to do all architecture configuration and troubleshooting. But on the contrary, on my left you have this full stack, and maybe work in the office or go in a data center to do the job. But right now, I will show you how AWS Architect Engineer looks like and how it works. So let's begin. Let's start with the requirements for an AWS infrastructure engineer. First, you need to understand basic network concepts, not deep understanding like Cisco's Adept. AWS has two types of subnets, public and private. As you can guess, a public subnet is publicly available. It has public and private IP addresses associated with it. A private subnet uses private IP addresses and its scope is based on RFC 1918 and RFC 6598. Now, you need to know just 4 CIDRs for IPv4, which is pretty easy in AWS. Isn't it? You have some new terminologies like Internet Gateway for short IGW and NAT Gateway, but these are easy compared to Cisco. You must also focus on AWS more on service quotas, also referred to as limits in AWS services. These are the maximum values for the resources, actions, and items in your AWS account and on AWS pricing. Pricing is very important. That's why I drew in my diagram with 2 NAT gateway, not 3. Also, you will be tested with EC2 instance types. As you can see, I put on EC2 instances in private subnets for security reasons. The load balancing concept is similar to Cisco or F5, but you will be tested deeply on AWS provided solutions like Application Load Balancer, Network Load Balancer, and Gateway Load Balancer. Something new to learn will be the auto-scaling group. AWS auto-scaling monitors your applications and automatically adjusts capacity to maintain steady, predictable performance at the lowest possible cost. What I need to explain here is the definition of AZ. You can read from AWS documentation that AZ or availability zones are distinct locations within an AWS region, which are engineered to be isolated from failures in other availability zones. For simplicity, AZ is a data center. We monitor infrastructure in Cisco and in AWS. AWS has very easy to deploy CloudWatch. I don't want to comment here on monitoring tools in traditional data centers. But I put an S3 bucket representing storage on my diagram. This is a huge AWS topic, but deployment is straightforward. DNS is another subject for both exams. You will study it from different angles for each technology provider. I want to introduce CloudFormation in this section, which you need to familiarize yourself with for the exam and your job. What is AWS CloudFormation? AWS CloudFormation is a service that gives developers and businesses an easy way to create a collection of related AWS and third-party resources and provision, and manage them in an orderly and predictable fashion. Now you can see the advantage of CloudFormation, infrastructure as code. That's amazing that a couple of hundred code lines can deploy the whole network infrastructure. Here are the things that we can see in this short presentation section of CloudFormation. We have the description, metadata, parameters, resources, and outputs. The resource section is very interesting. There are a few lines of code describing VPC, including tagging, and another section that enables VPC logging, with logs available in CloudWatch. Internet Gateway and VPC Gateway attachment. NAT getaways in 2 public subnets. Public subnet in Availability Zone A. Private subnet in Availability Zone A. Public subnet in Availability Zone B. Private subnet in Availability Zone B. Public subnet in Availability Zone C. Private subnet in Availability Zone C. Routing table public and private for subnets in Availability Zone A. Routing table public and private for subnets in Availability Zone B. Routing table public and private for subnets in Availability Zone C. Routing table association for public subnet A, private subnet A, public subnet B, private subnet B, public subnet C, private subnet C. Network access list for public subnets and for private subnets. This is an example of network ACL entries. Subnet Network Access List Association for public subnet A and private subnet A. The last bit is outputs. Those are parameters we use in the following CloudFormation template to deploy the application stack. This is the last AWS technical section in this video. UI is crucial for AWS engineers, especially in checking configuration, logs, troubleshooting, and deploying resources. Based on our design, I will show you how to deploy network infrastructure using AWS UI. So let's start. First, create VPC, then we need to fill the form, VPC name, and IPv4 SID block. I will stick to defaults and other parameters. Now we have successfully created VPC with the given parameters. The second step is to create subnets. We need to select our VPC ID, input subnet name, select availability zone, and add IPv4 CEDR block. Then, submit a request by clicking Create Subnets button. This time, the first public subnet in AZA has been successfully created. The same steps are for the public subnet in AZB. Select our VPC ID, subnet name, availability zone, and IPv4 CEDR block. Submit request by clicking Create Subnets button. For the public subnet AZC, we will conduct using the same steps, just like we did previously. Select our VPC ID, then subnet name, availability zone, and input IPv4 CEDR block. Lastly, submit a request by clicking Create Subnet button. Let's now create subnet for the private subnet in AZA. Select our VPC ID just like what we did earlier. Then select again subnet name. Next, availability zone, and input IPv4 CEDR block. To top it all, submit a request by clicking Create Subnet button. Now we have for the private subnet AZB, and we will create this subnet similarly. Lastly, we will now then create the private subnet in AZC. We have now created 3 public and 3 private subnets. Step 3. Create an Internet gateway. The next step after successfully creating IGW is to attach it to VPC. Quickly double-check your VPC ID. And it's correct. Step 4. Create NAT gateway in 2 AZs. Then we provide name, subnet ID, and allocate elastic IP. Very well. We have now successfully created NAT gateways, which are still in a pending state. We will do the same configuration procedure for NAT gateway in AZB. And that's another success in creating a second NAT gateway. Step 5. Create routing tables. Let's provide name for VPC ID. We have now successfully created a public routing table. And these are the exact details for the private routing table. Now we just created successfully a private routing table. The next step is to add routes to each routing table. We are now adding a default route pointing to Internet Gateway for the public routing table. We are adding a default route pointing to NAT Gateway for the private routing table in AZA. We must also create an extra private routing table to associate NAT Gateway AZB with the public subnet AZB. I am changing the routing table's name to make naming more consistent. Then adding the default route with the target of NAT Gateway B. Let's now associate our routing tables with subnets. We will associate the public subnet in AZC with the public route table. Then associate the public subnet in AZB with the same public route table. Then associate the public subnet in AZA with the same public route table. Then double-check. The next step is associating the private subnet in AZA, B, and C with the private route tables AZA, B, and C, respectively. And those are the examples of working with AWS UI. Now, I'm going to subjectively compare Cisco CCNA and AWS Architect Associate, based on my opinion, knowledge, and study from my years of experience. Let's start with study efforts. With Cisco CCNA's study efforts, it's extremely high compared to AWS Architect Associate, because your knowledge should be very wide and deep. And you need to read a lot of books, check the documentation, and do a lot of hands-on practice, not just on a virtual machine but also on real switches and routers. When it comes to study costs, it's much more costly with Cisco CCNA because we need to invest in expensive books, Cisco switches and routers, cabling, and buying all other stuff for a physical lab. We will also need a very powerful computer to do a virtual lab. Altogether, it's very costly. On the other hand, in AWS Architect Associate, it's very pretty cheap because AWS will give you a 1-year free account. That's extremely good for students because you can use it for study out from AWS free tutorials, documentation, and cheap AWS training. So that means study cost in AWS has a vast difference. In Cisco CCNA, you can spend roughly hundreds or even thousands of dollars, whereas in AWS it's just tens of dollars. Let's move on to exam difficulties. In Cisco CCNA, it's more difficult because we need to pass at least 85+%, while AWS varies just around 65% to 70%, which is easier to pass. Cisco CCNA is very difficult and specific when it comes to exams, but in AWS it's more intuitive, so it is easier to answer, based on your knowledge and logic. Then considering the scoring percentage, it's quite easier in AWS. Then we have the comparison between reading documentation in CCNA and AWS. In my opinion, you need to rely on AWS documentation because Cisco they rely more on documentation and books. Reading documentation and reading books is highly prioritized for Cisco. But for AWS, reading documentation is highly prioritized and can skip reading books for exams. In lab preparation, AWS is more focused on lab preparation than Cisco. You need to focus on practice to see what's behind the technology using their services, so lab preparation is essential for both. But in Cisco, it's not as important as in AWS associate level knowledge. However, Cisco's device or equipment knowledge is very high, because they focus on the configuration in physical boxes and parameters, but opposite to AWS, because we don't have this stuff. We have a virtual machine. You just have to know how it works, but not very deeply like Cisco. Again, Cisco is focused on the device configurations and parameters, but AWS Architect is more focused on services and not on the equipment. But how recognized are the certificates between Cisco CCNA and AWS Architect Associate by employees and other engineers? I think Cisco CCNA is a little bit more recognized than AWS Architect. Well, just a little bit. This is because Cisco CCNA has been in the market for over 25 years, while AWS Architect Associate was launched around 10 years from today. But regardless of the time difference since the two IT giants were established, subjectively I can say that AWS has been significantly competing and can be number one in the IT industry and is the leader specifically in public cloud technology. Lastly, prestige. Well, Cisco CCNA is more prestigious than AWS because, as I mentioned, they started longer than AWS. But it doesn't mean AWS is far from it. AWS Architect Associate is also very prestigious despite being launched lately, and it goes to show that they can do better than Cisco in less than 25 years. To summarize everything, I can say that AWS is the best option for new engineers based on the data comparison listed. Less effort, high prestige, very well documentation technology, and study costs are very low compared to Cisco. Well, there are other factors why AWS is the best. Two of these are in getting your first job at the high salary, but it will be discussed in our incoming video, so stay notified. So there you go. AWS is the winner of the competition. Remember to take notes about what has been covered. Review your notes because it will be a learning step for you, and a key in mastering this technology. Thank you so much for joining me, and I had a great time in this video. Looking forward to having you in the next to come. And I hope this has been very informative for you, and I'd like to thank you for watching. Don't forget to like, subscribe, and be sure to click the notification bell for you stay updated on my next video. See you next time, gurus.